Hi, this is Ganesh Elgati. Today I am going to discuss about transaction and concurrency. Firstly, what is meant by transaction? Transaction is a set of logically related operation and it performed by a single user to perform operations for accessing the contents of database. And it also contains a group of tasks. Let us consider a daily life example, which is X person went to a market and bought 50 rupees vegetables. Now he has to transfer 50 rupees from his account to seller account, which transaction consists of T1 and T2, which is T1 is his X person account and T2 as seller account. In X account, first he has to open his account, which consists of A amount, and before paying, before balance equals to A dot balance, after balance equals to before balance minus 50 rupees. Now A dot balance equals to after balance and has to close his account. Close account A. Now coming to T2 seller account is open account consists of B amount before balance equals to B dot balance after balance equals to before balance plus 50. B dot balance equals to after balance and close account B. Here 50 is detected here and added here. While, while talking about operations, there are two types of operations in transaction. One is read and write. Read describes about it is used to read the value of X from the database and stores it in a buffer in main memory. While coming to write, used to write the value back to the database from the buffer. Now we'll discuss about transaction properties, which is known as ACID, where A is known as atomicity, C is known as consistency, I is known as isolation, and D is known as durability. Let us go with one by one. First one, atomicity. Atomicity is described about, it states about that all operations of the transaction take place at once. If not, the transaction is aborted. Let us consider an example. Let us assume T is a transaction which consists of T1 and T2, where A consists of 400 and B consists of 300. Now we need to transfer 200 from A to B. Read A, then we need to transfer 200 from A to B and write A. Then read B equals to 200. Now write B. Firstly, A consists of 400, 200 is deducted, now which consists of 200, where B consists of 300 plus 200, which consists of total 500. Now it commits, which is permanently stored. Error occurs in the transaction, it rollbacks to starting state. Now let us consider second one, consistency. Consistency, it is an integrity constraint are maintained so that the database is consistent before and after the transaction. From above example, where A consists of 400, before the transaction 400 A and 300 B, sum equals to A plus B equal to 700. After the transaction, A consists of 200 and B consists of 500. After the transaction, 200 plus 500 equals to 7. Before and after the transaction, both are same. It is known as consistent. Now third one, isolation. It shows the data which is used at the time of execution of a transaction cannot be used by the second transaction until the first one is complete. Now fourth one, durability. Durability states that it used to indicate the performance of the database consistent state if states that the transaction made the permanent changes. Now I am going to discuss about states of transaction. It consists of active, partial committed, committed, terminated, fail, abort, etc. Now let us start with active. Active, it says first step of every transaction. It is a first step of every transaction. In active state, we can read and write, for example, like insert, delete, update. Now coming to partially committed, a transaction executes its final operation, but the data is still not saved to the database. Now committed state, a transaction is said to be committed state if it executes all operations successfully. If it executes all operations successfully, it is known as committed state. In committed state, the effects of now are permanently stored in database. If any of the checks made by the database recovery system fails, if any of the occurs in the active state, it goes to failed state. If the transactions fail in the middle of the transaction, then before executing the transaction, all the executed transaction comes to fail. Now, after the failed state, it rollbacks to initial state from the properties of transaction, like ACID properties, where atomicity, if the transaction is failed in middle, it rollbacks to initial state, and at last it terminates. Thank you. In next session, we will discuss about schedules.